So basically this will be a video based on learning objectives in regards to reverse phase HPLC. For the first learning objective, I have to discuss about the stationary phase and mobile phase. And as you can see here, which is a picture of a column where it gets expanded out into a more specific diagram. You can see the mobile phase, which is dotted lines, and then the stationary phase are black circles. Well, basically, the mobile phase for reverse HPLC is polar. In other words, it's hydrophilic. And the stationary phase over here, it's unpolar and hydrophobic. So when we have a sample that's unpolar, when it goes through the column, it's more likely to adhere to the stationary phase, because the concept is that it's likes like. So unpolar will like unpolar, and then polar would adhere to polar. So if we had a polar compound, it would more likely not interact with the stationary phase and will just follow the mobile phase and be eluded very quickly. For the second learning objective, we had to identify parameters which influence retention factor and establish the rules governing the retention factor. So basically, the retention factor is the measure of how long a sample actually interacts with the stationary phase in comparison to the time spent in the mobile phase. And here I have an equation for you. So retention factor, which is K, is retention time minus unretained time divided by unretained time. And so the most effective and convenient way to alter the retention factor of a peak is to basically adjust the solvent strength of the mobile phase. So you can make the mobile phase extremely polar, and this will affect the retention factor. You can also change the polarity of the stationary phase. So if you make the stationary phase extremely unpolar and the compound itself is unpolar, it will more likely adhere to the stationary phase and then be retained into the column a lot longer. Also, the polarity of the sample might play a role. And finally, the flow rate. So if you make the flow rate a lot, you can make it a lot quicker, you can make it a lot slower. So task 3 is establish a relationship between retention factor and resolution. Basically, resolution is the extent to which a column is able to separate peaks from one another for better clarity. I'll show you a diagram which is an animation. So basically changing the retention factor, which is K, from values between 1 and 5 has the largest impact on the chromatographic resolution. For here you can see that at the moment the retention factor is on a value of 3, but like if you change the retention factor to around 10 or above, any increase in K makes very little difference to the resolution. But however, like if you lower the value of K to somewhere less than 1, as you can see I'm moving the animation right now, you kind of find that it's difficult to obtain a meaningful separation. See, you can see from here that the separation is almost unnoticeable, and until it reached to a unretained time where there is no resolution or separation at all. But it's actually very simple to change K, and it's often worthwhile to adjust the K range of peaks within the chromatogram to obtain optimum resolution. So finally, the last learning objective is to identify the factors that influence sensitivity. And basically, sensitivity is the degree to which a detector is able to pick up on a sample interacting with the stationary phase. Factors that could influence it is like the amount of sample injected. So like if you had very little amount, obviously it's much more difficult for the detector to uh, see influence in the sensitivity. Like also another factor would be adherence to the stationary phase. So if an unpolar molecule was retained in the stationary phase for a very long time, this would obviously affect the sensitivity. Another factor would be the type of detector used. So if you used a more modern detector, it's more likely to show better results, rather if you use maybe a more outdated equipment, then the sensitivity might become an issue. And lastly, another factor that we need to consider is the transmission efficiency of the lens system and the rod system. So basically that's all my 4 learning objectives, and I hope you enjoyed the video.